learn how to test for symmetry algebraically. So if we're given an equation and we don't have the graph to look at, we just have the equation. So let's recall what the graph of an equation is. It's the set of all points x, y that actually satisfy that equation. Now if something's even, let's say we have something like this. If we have any point on there, x, y, so here's x, here's y, because it's even, I can flip the x around to be negative x, and the ordered pair negative x, y is also on the graph. So a way to test if something's even is to replace x with negative x in your equation and see if you get the same thing back. Because if it's the same thing back, it satisfies the equation. Now if it's odd, say it looks something like this. If you have ordered pair x, y on there, so x and y, you're going to have negative x and negative y also on there. So a way to test if something's odd is replace x with negative x and y with negative y in your equation and see if you get back your original equation. Let's test y equals fifth root of x minus 3x for being even or odd. So for even, we're going to replace the x with a negative x. Okay, well, this is the same as the fifth root of negative 1 times the fifth root of x, because this is negative 1 times x. This will be plus 3x. And the fifth root of negative 1 is negative 1. Okay, so this is not the same as that one, so it's not even. Let's try odd. Okay, we replace y with negative y, x with negative x. Okay, we already did the right-hand side previously, so this will be negative fifth root of x plus 3x equals negative y. Is that the same as this one? Well, we have a y on the left, so let's multiply everything by negative 1 and see what happens. This will be a y equals fifth root of x minus 3x. Is it the same? Yes, it is. So this equation is odd. Let's test this equation for being even or odd. Okay, y stays the same, replace x with negative x. Okay, so we have a negative x plus 1. Okay, negative x quantity cubed. We have a negative, 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 so it ends up being negative. Alright, is this the same? Well, we might want to multiply the numerator and denominator both by negative 1 to get an x cubed in the denominator, so we can better compare. So this will be an x minus 1, and they're not the same because of this minus. Now let's test odd. Okay, replace y with negative y and x with negative x. Okay, so we already did our right hand side. So we have negative y equals x minus 1 over x cubed. Let's multiply both sides by a negative 1. we're going to get y equals, now I can choose to multiply that numerator, that -1 by the numerator or the denominator. I want the denominator to be x cubed, so I'm going to leave that. So this will be -x plus 1 all over x cubed. And it's not the same. This has a -x where this has an x, so this is not odd. Well, we're not even and we're not odd, so this one is neither. It doesn't have either of those symmetries.